We will start today with a webinar concerning GNSS in the robotics field. We have Gustavo López from the Septentrio, a very famous and popular company in the GNSS world, in particular for manufacturing receivers for any kind of applications today. This is the second time that he's coming in the GNSS Academy. The first time he was giving a talk in GNSS vulnerabilities and resilience and spoofing and so on, right? But today we will address the topic of GNSS in the robotics field, which is maybe an unknown field for a lot of people, right? Because GNSS, we are always talking about transportation, drones, airplanes, maritime, railway, and so on. But robotics is one of the most popular also field of applications for the GNSS. Maybe Gustavo, you can introduce yourself. What are you doing? What is your background? What are you doing in Septentrio? And we can go ahead.
Sure, thank you. Thank you very much, Eduardo, again for the invitation to this talk. I'm very happy to share some of the experiences that we have had in Septentrio. I'm Gustavo López, Market Access Manager in Septentrio. My main role is actually to look for what's the strategy for applications 5 years from now. So it's really a vision type of emergent type of applications. So robotics, UAV, and there is many other type of use cases which where you can see GNSS. So I'm very happy, of course, to talk about some topic which I find quite passionate from my side as well. I've been already busy also quite a lot in UAVs from the past, but now robotics is indeed a big topic, as you mentioned it as well. No? So I've been working almost 20 years, as I mentioned, in Septentrio. So I started mainly as a software engineer, so I have a technical background, and then I managed the R&D team later on, and then finally I moved more to the commercial side, but still with a very important touch to the technology, as you can imagine, on GNSS side. All right, so let's go ahead. So indeed, the topic will be robotics, and indeed how they go hand in hand with the GNSS technology side. I'll just start a bit with a very brief interesting quote here, and this is from Bits. This is actually that we normally always overestimate the change that will occur in the next 2 years, but we also try to underestimate what will occur in the next 10 years. And if you look at what's happening also in robotics, it's something in that area as well. There is nowadays, you will see in my presentation, lots of use cases, lots of applications that we get to see in the robotics side, lots of estimations and lots of media that is talking about robotics aspects. In the other hand, a lot of the volume or the adoption of the technology will still take some extra time. However, when we are talking about 10 years, you will see that this is going to make a big change in the technologies and in our daily lives, especially in the robotics aspects as well. So very interesting to see that that link. Yes, as you mentioned, I have indeed a bit of information about Septentrio. So who Septentrio is a company developing GNSS high-end technology. We are based in Belgium. Leuven, Belgium is where we have the headquarters. We have now some also development offices, research and development in Espoo, Finland, and we have sales and support offices worldwide. So you will see offices in America, China, Japan. So I'm talking to you right now from Belgium. We have a team of around 120 employees, but yeah, as you can imagine, the technology is becoming available everywhere. So we have a really real national team behind as well. And our main focus is to have technology that is accurate, reliable, and especially secure. Really, the high-end type of applications is where we try to focus a lot. So we serve different type of applications. You can go from very heavy automation machines, as an example, bulldozer or an excavator, where you get to see a lot of RTK accuracy systems, agriculture or mining autonomous trucks, all the way down to robotics. So UAV, as I mentioned, has been an important market also for Septentrio, and indeed nowadays we get to see the start basically of that robotics market, which is growing in important areas as well. We produce different type of GNSS receivers, all the way from house receivers all the way to very small modules that you can integrate in this type of system. So we definitely get to see the demand for smaller systems easier to integrate in smaller machines as well. So yeah, very interesting to see the technology and how this is changing as well. Well, maybe I have presented that in some other talks, but this is what I call the democratization of technology. We have now GNSS available everywhere. We get to see it in different type of applications, and we are even getting quite close to consumer applications that are requiring that high accuracy elements. Before RTK was really for the experts, and it was only a few companies that were producing that had that expertise. But nowadays, indeed, this technology is becoming available. The cost is going down, the technology is really becoming accessible, but that's also making a lot of opportunities in terms of the type of applications that are using the precision of GNSS side as well. So this is definitely great news, companies like Septentrio, but that means also that we need to change the way how we create technology in the market, technology that can be accessible for this type of applications. As an example, creating a module that can be used in a drone, in a very tight drone, or in a robot that can be a very small robot using that technology. So definitely very interesting in this market. Definitely there are some elements of security in the GNSS area. As you mentioned, we had a talk in the past about resilience, so that's a separate talk, which is also interesting to see, and it's an aspect that unfortunately there is still not a lot of education out there for the integrators of applications. So that's really also important to consider. So how this autonomy came? There are two areas of two branches how this autonomy came. First of all, it came thanks to the autonomous car research. So all these autonomous vehicles, basically self-driving technology, is basically what started to create the questions of, hey, we should have a cheaper GNSS module, we should have still more sensors integrated, and then have that full autonomy for the system. But of course, there are still the demands of safety, reliability, accuracy behind those type of applications. But as you can imagine, several OEMs in the car industry are definitely on that. What happened? COVID came. I can tell you those L2, L3 of autonomy, they got delayed. Bit of delay in that autonomy on the systems. Yes, companies keep doing the research on that, keep investing on that, but as you know, indeed the automotive market has a bit in the last years. So those projects have gotten a bit of delay. But there are other projects basically that started to use this technology, this idea of autonomy that started to boom a lot. And that's actually the robotics market in particular. And when I'm talking about robotics, of course, mainly I'm talking about ground robotics, but it's also the UAV type of drone applications that started to boom. So this is very interesting to see. A lot of the technologies, especially on the ground robotics, are inheriting some of those aspects of autonomy coming from the autonomous car technologies. And then you will see that a bit on how the rest of the slides talk about that autonomy and how we integrate GNSS next to other sensors as well. But let's try to first define is, and I think that's maybe a very simple thing. But yeah, a robot, you may have definitions that say, okay, it's just an artificial agent that is working in an environment, in a physical world side, is programmable, it has multi-functions, it can be manipulated in order to perform different type of actions or motions in order to perform tasks. That's what you want to do there. The word robot came mainly from a writer basically in Czech Republic that was making a play, and basically he started to use the word of robot, which is now called robot nowadays as well. So it's of course not a new word there. This is actually the guy, you can see the Czech guy that invented. And that's basically the general term of that definition. Is indeed is a system that is trying to imitate and do actions in an intelligent way, very similar to a human. And in order for that robot or machine to be able to do some work, it has to do the following. It has to do some sensing, perception around the surroundings of what's going on. It needs to perform certain specific tasks, call it locomotion, manipulation, or something with arms, or some specific implementer technology there. It has to be reprogrammable with different type of skills, different type of actions, and then more important indeed is that it's autonomous. It's really running autonomous. You will see even already today there are a few applications that are kind of remote control. I would not really call that a robot. For me, a robot is really something that is having a full autonomy for the different tasks as well. Types of robots you will get to see, and these are just some technologies that you will find in when you are talking with people that the robotic experts. They talk about sometimes service robots. What's a service robot? That's actually, as an example, a security guard robot, a delivery robot, a cleaning robot, mowing robot. It's doing a service for the humans, basically, or for the task that are to be done there. And there are some assistance robots, which is a bit more in the mobility or as for elderly people, where there is also quite some research also in trying to bring some autonomy behind that. As you can imagine, some of those service robots are, of course, indoor type of applications, but we get to see more and more outdoor applications, and therefore we see the use of GNSS technology as well. Robots have, of course, their manipulators. I think many of you, of course, have been used to see this type of arms where you have a robot, and that's what you get to see the robots in the manufacturing. Many people, when they talk about robots, they are talking a lot about manufacturing in factories, in production facilities where you have these real automated processes. But these arms, basically, they started to now be used in outdoors type of applications, maybe not with the same arms, but with the same philosophy of movement, of doing different type of actions, and the technology is also becoming much more available as well. So here, a bit of the outdoor type of robots that you will get to see in what is called the different locomotion. Yes, aerial robots, which is the drones, the UAVs, is also considered many times a robot, a flying robot. You will get to see nowadays wheeled mobile robots. You will get to see a bit the examples later, but this is indeed robotics that are helping for delivery or for other type of actions, but that they need certain wheels in order to navigate maybe in the same routes that we are using, or in the sidewalks or something similar. You will have these, and maybe you have seen some of these ones look scary, but actually they are interesting robots, which is the leg robots, and they have amazing technology on the mechanical movements that they implement. A lot of artificial intelligence on how the kinematics of navigation are happening in this type of robots. And you will see, of course, some humanoids. Well, humanoids, I would say, normally there is not real GNSS. Most of these humanoids possibly are working in a service, hotels or something like that. But what you get to see still as well is a lot of marine or underwater robots as well popping up in the market. So why are people using robots? Definitely there is the 4D element, I call it, which is they are trying to go to dangerous places. They can be useful because they can go to dirty places that people don't want to go. They can perform dull tasks, which is basically monotonic, repetitive tasks that we don't want to do, or they can perform tasks that for a human is not possible. So that's definitely one aspect. And in terms of the task, basically, that they are doing, they can be helping, of course, in automation, in augmentation of information, in assistance, and again, this autonomous aspect that I mentioned to you. But I think basically people are trying to optimize a lot these processes and that's where robots are making a lot of sense. Why? Because they are bringing quality. They are really increasing the quality that you have in certain aspects where maybe a human cannot go to the inches or to be very precise in terms of handling some specific tasks. It can also bring efficiency side, because people get tired and robots, okay, they have a battery, but they could continue working for different hours. The safety element, you don't want to always have a person working in very dangerous situations. So yes, you could send robots as well to those type of environments. And then you can also, of course, reduce some cost in different areas and increase the productivity because people can be busy with other type of activities there. So this is very generic. And then we see, okay, what is the robot trying to solve as a problem itself? How is trying to that link with GNSS? Well, the first thing that the robot is wondering is, where am I? I mean, where am I located? Because it needs to start moving somewhere around there. How do I get there? It needs to move from one point to another point in order to perform a specific task, right? So this is the important elements, which is localization and the pathfinding, where the GNSS, of course, makes a very important sense here. There are other problems, of course, that the robot is trying to maybe as an example, the object recognition. Many of these robots are doing analysis in industrial plants, in agriculture and other ones. So they have made some vision in order to detect some elements there. And of course, the robot needs to understand certain language in order to be programmed and also to maybe answer basically the result or the actions that is performing as well. So this is normally the generic problems that a robot needs to be solving by itself. But again, the top ones is where we are linked. And you can see it a bit more here in this diagram, how those intelligence of the robots are happening. And there is a lot of, again, algorithms behind the robot, a lot of artificial intelligence, a lot of control flow loop in order to handle a full robot. A robot, in that case, we could consider it name an agent. That's normally how in robotics is the terminology that is quite used. And it has some effectors, which can be arms, which can be implementers doing specific actions in the environment itself. Those robots are also taking some perception, maybe vision, capturing information in order to take decisions or to provide reporting information or warnings to the users of those robots. And more important, they are working with sensors. I think that's basically where we come in place. Sensors, yeah, they need to be detecting obstacles. They need to be navigating from one point to the other in a safe way, etc. So yes, again, the GNSS aspect is where it comes in place, these sensors. And many of you have heard about sensor fusion as a topic. What is sensor fusion? It comes from all this autonomy, and that's basically it is the use of multiple sensors in order to perform a navigation aspect. And again, GNSS also is quite important in those sensors there. So again, robotics of yesterday, we were quite used to robotics only existing in manufacturing, in the different plants, and this is the type of robots you were seeing in the past, but those robots are really going out of the factory floors. Now they are having legs, they are having wheels, they are having different environments in order to work outside. And you will have entertainment robots, you will have personal services robots, medical applications, you have hazardous environments, space. So we have heard about the Mars rover as well in Mars, in the space, underwater robots, and again in that outdoors applications. Mainly, I will mention here agriculture, mining, construction, harvesting, logistics, Security and defense, of course, is an application that we have seen already for some years. And there is also some sensing. So some of those robots are not only doing a specific automation task or implementing certain actions, but some of them are also doing some sensing or analysis of the environment in order to detect, as an example, diseases in the agriculture, or mapping, or sensing, or some other aspects there. So these are applications that you will say, okay, but are they really existent? Yes, these applications are now really factual and growing quite rapidly in some specific areas as well. As I mentioned, some of those autonomous systems could be also underground vehicles in the marine side or in the air side as well. So yes, they could also be considered some of the robots. But yeah, all these systems are transitioning from the standard remote control that people used to have to an autonomous control behind. So here some you can already see some cool applications on the top, some of the animations here. Let's start with some of them very briefly. I'll go a bit more detail later on the requirements that these applications have. But yeah, agriculture is moving to robotics quite a lot. And I will say this is a market that will really expand quite a lot in the coming years. You will see that there is a big problem in agriculture, lots of people to be fed. So yeah, there is an important need in agriculture. Delivery, you might have seen a bit of this in the news. Sometimes there are delivery robots mainly in universities nowadays, delivering food, delivering packages, delivering different things. Is what is normally called the last mile delivery problem. And I will also talk about those problems and why people are bringing solutions there. Here, a marine robot can perform different tasks, which sometimes are difficult with a human in a boat, as you can imagine. So with small robots, you can do quite a lot of analysis and other type of tasks. Mowers. I'm sure that some of you maybe have heard about these robotic mowers, and this is the big volume application nowadays in RTK. I can tell you before RTK was used only on certain high advanced type of machinery, but nowadays many people are starting to have an RTK setup on their home because they are having a robotic mower, and that robotic mower needs to do precise positioning in order to avoid the problem of the geofencing, right? So this is a very interesting application as well, robotic side. Other ones could be surveillance, cleaning robots. Nobody likes to do cleaning, so indeed it's a type of typical task where this could be used as well as snow cleaning, right? So which work very similarly to the agricultural robots. They use the same type of concepts and the same type of technology in those aspects. So as you can see, these are auto robotics, and yes, there is a link of GNSS and how the requirement of that precise localization is quite important. The precise to have a safe positioning as well. And as you can imagine, these robots are now operating very close to humans. And some of the robots can be small, so you don't really worry too much, but these robots can also be quite big. So then you might worry also about how can you do a bit of better safety or even certification questions that are happening nowadays. In the same way that happened with UAVs, we will get to see those limitations of certification, and that will come in the coming years as the technology becomes more available as well. So yeah, it's all about autonomy and how we handle that autonomy. Well, it's nothing new at the end. As I told you, it started a lot with mainly steering the user, and this is very similar to what we get to see in cars nowadays. There is a cruise control nowadays, and that cruise control is becoming more and more advanced as well, thanks to the different sensors that are integrated in the vehicle itself. Well, the same is happening in all the different other markets. As an example, in 2002 or around those years is when the precision agriculture market started to explode with high precision GNSS itself. So it was already the advanced application. There was still a driver, but the tractor was already driving by itself. So there was already, and this is nowadays is still the case. Many use cases with steering, is many steering applications there. It happened then with mining, and I would say in terms of autonomous, fully autonomous systems, I would say mining market is the most advanced in those aspects. You will see all these big haul trucks which are operating in pit mines, which big vehicles, they are fully automated and operating autonomously, because there's a big problem of safety in those areas as well. Drones, yeah, it started to explode around the year 2015, so that's already the case. All these systems are really fully automated. There is even more further automation, as an example, a swarm, which is multiple drones working all together. So there's quite a lot of research and development in that side. And yes, as I told you, definitely there is some activities also in the autonomous area. As an example, today, Septentrio is providing some technology for an autonomous car in California, which is Rivian, a very nice vehicle that you will find only there, which is having some fully autonomy also behind. So very interesting to see those aspects of autonomy. So again, very briefly, we said the robot is asking, so where am I? What's around me? Where am I going? How do I get? Those are the navigation type of questions that a robot is asking. Normally, how you respond to these questions, well, you need to do some sensor interpretation. What are the objects that you may have in the vicinity? What is the localization? And some localization could be done, which is many people in the robotics side are also using mapping, best maps. And this is when we get to talk about HD mapping, high definition mapping, high resolution mapping. And those high resolution mappings are sometimes used as a localization element, because you have cameras, and if you see an object, then you could also navigate on that. And then you have, of course, the path planning, which is, as I told you, take the decisions of moving from one place to the other in the most efficient way, in the kind of the problem of the TomTom or this type of GPSs, find me the best route in order to navigate from one place to the other, but in all types of environments there. So it's all about sensors. I put a big I here on the sensors and how they interact in real time with the environment. So again, these robots need some perception of the environment. And what you will find is that there are different types of sensors out there. And all that information has to be integrated in what is called normally the control loop of a robot. And that's basically just a loop that is getting all the information and then doing some intelligent Kalman filter. Maybe you have heard about Kalman filter, which is used in GNSS to compute a position. Oh, the same is happening in a robot. They are using all those sensor information in order to compute a new site. So, okay, yeah. But in general, what type of sensors could a robot have? You might have light sensors, which are maybe the presence, the color intensity, the direction, even some very interesting sensors there. Sound sensors, some be detecting presence also by sound, by frequency, intensity. I was talking as an example to one of these robotic mower companies. They also have a rain sensor, because if there is rain, they need to get back to the base in order to keep the robot safe. So very interesting also to see those type of sensors, heat sensors, temperature, magnitude, wavelength sensors, chemical. If you go to industrial plants, there is a lot of these robots now, these leg type of robots, like dog robots, which are operating in plants because there is a lot of stairs, there is a lot of different environments, so they cannot operate with wheels. They need these legs to operate there, and they have these chemical sensors in order to detect maybe a leak of a specific concentration behind. Proximity, I will say this is definitely very important, because you need to avoid collisions. So that means you have presence, absence of obstacles, and avoidance. This happens a lot in mining. One of the most important applications in mining is obstacle avoidance in order to avoid crashes as well. So the same is happening with other smaller robots nowadays. And then, of course, the orientation, the attitude, and the position, where again GNSS becomes relevant, and also not only GNSS but also GNSS INS, inertial systems that are combining a GPS together with an AMU, which is a measurement unit which is working in a kinematics mode as well. I'll talk about that in a minute as well. So again, those are the sensors that are used, cameras, magnetic sensors. Those are the names of the electronic components we'll find, orientation sensors, GPS, of course, compass sensors, voltage sensors, and the other ones we mentioned. But when we are talking about navigation, these are the type of sensors that are used. Visual navigation, I would say, is something that is also evolving quite a lot, and I would say is one of the more important elements used in navigation of a robot or of an autonomous system, especially coming from the autonomous cars. You have seen autonomous cars now with cameras everywhere. So yeah, a visual definitely very important there. Magnetic sensors are still also used together with orientation sensors. I mentioned an IMU as an example. So a lot of IMUs used in this navigation, and yes, of course, GPS system as well. Now, many people were thinking that GPS is not needed, and I can tell you companies as an example, like Tesla. At some point they said, well, we don't need GPS. We can live with a camera. We can live with my infrared sensors and with all the other sensors and gadgets I have put in my car. That was basically the perception that people were having at the beginning of the autonomous area, I would say. But this has changed, luckily, luckily for companies of GNSS, but also luckily also for the safety of these systems. What you will see is that even if you have those sensors, many of those sensors are environmental sensors. So they will be not working if you have rain, if you have snow, if you have maybe not enough visible objects. As an example, if you are in the desert, you will not have, you may have a map, but the map will not help you at all, because the map doesn't really have objects that you can recognize for the navigation aspect itself. So that element of absolute navigation is really important, and that can only be obtained by combining a GPS system with the rest of the sensors. So the rest of the sensors definitely will help, but the combination of all those things will definitely help the full navigation of an autonomous system itself. So very important to realize, yeah, you are doing studies on GNSS, so GNSS will remain itself. Definitely lots of study of finding alternatives to GPS, because GPS is not working everywhere. Indoors, as an example, is an important problem, but again, GPS still will be used for most of these systems for many years until there is another good alternative technology behind.
I would just
sure.
Yes, sorry, Gustavo, just
no,
I would even say that even those companies that are not using GNSS because of the urban environment, like buildings and so on, and GPS and GNSS is a little bit limited, right? They are even using GNSS for the synchronization of the different sensors, right? Because at the end, you need a very, very high capacity of synchronization in the levels of nanoseconds in order to make sure that every sensor is working properly, right? Then, of course, in several environments, you can get rid of GNSS, but then you have to put a lot of millions of sensors, right? But even though you need some kind of atomic synchronization, I would say, right?
That is true, and it's a very interesting point indeed what you mentioned, because and indeed GPS started to be used not only for the autonomy, as we mentioned here, of positioning, but for timing. And that was a lot also for the communication, because all these autonomous, as an example, cars, they will start to operate and they will have to be connected. So again, there is a very important problem of latency of communication if you want to have a safety of these vehicles operating, all of them working together. So V2X applications and several companies, as an example, NXP or other companies that are implementing what is call the telematics of the vehicle, they need GPS. They need GPS for the time inside. So yes, this is just a bit talking about again on that sensor fusion, how it works, and it's a lot of artificial intelligence, more or less, that is kind of used sometimes. A lot of the vehicle recognition in objects, etc. But and they are using in the GPS sense, they are using the mapping information, which is based a lot of on artificial intelligence and recognition behind it, and of course a semantic understanding of all those things in order to have a loop of the continuous navigation aspect. But yes, if you want to have a safe vehicle, you will need a safe GNSS technology as well, which is not only accurate, but it's also giving you proper error information so that you can discriminate the sensor. As an example, if the GPS tells you, I am here, but in reality it's maybe 20 centimeters away or something like that, yeah, you could basically have a safety problem as well. So you need reliable error reporting from these sensors in order to give the right weight to rely on the proper sensor in the different environments as well. So very important to consider that as well. I will go now to the use cases and a bit the requirements that, as we get to see them in the market. Well, you will see here again some of those applications here, and I will go a bit more on detail of those use cases: logistics, ag robotics, drones, mining, and the delivery aspect itself. So let's start with agriculture. And as I was telling you, for me, well, agriculture is something that at least on my role of prediction, I would say it's something that has to grow more. Right? It will have to grow more because there is a big problem. There is a big problem of labor in order to satisfy basically the demand that is needed in the agriculture market. People are basically moving away from the farms. Young people don't want to work in the farms anymore. So people are migrating to other areas for sure. So this is a big problem in that aspect. And there is also geopolitical issues as well in terms of migration. Before there was a lot of migration that was doing this type of agriculture aspects. And now this is also becoming a problem as well due to political environments. So the demand for autonomy is growing quite a lot. This is just to show you here basically the labor aspects of how it's evolving in Europe, and you can see it's basically reducing quite a lot. So you need to satisfy this with autonomy, and agrobots is the best way to do that. And this is maps to the agriculture, which is the bot evolution. Very long time ago, the tractor came and everybody was very happy. It was already some things in a more efficient way. Then there was a green revolution in order to do more agronomical practices, fertilizers. Then these planes started to do a bit more precision culture as well with yield monitoring, environmental applications. And then more digital farming, which is also what we get to see nowadays, a bit much more information about what's happening in the agriculture side. But yeah, robots are also entering the agriculture market with two applications. One is the robot side, and then the drones themselves applications. Robots are doing harvesting. Robots are doing weeding that also before had to be done. Drones are doing inspection, as an example. They are also doing fertilizing. As an example, I find it kind of some of the regulations take a long time, as you can imagine. Fertilizing in Europe is prohibited to be done by air. That was also, of course, due to ecological reasons, because there were these big airplanes that were basically putting fertilizer everywhere. So in places even where it was not needed. So what they say is no air fertilizing. So what happened is that people started to do it on the field in certain places where they would find it relevant. But drones can do it much precise. Drones can go and target a very specific plant and move to the other plant, etc. While people, when they are just fertilizing, they are also fertilizing in a less efficient way. So you could even use drones in a better way. But today, indeed, there is an aspect of, unfortunately, of adoption and understanding in that market in order to make it available there. So yeah, the evolution and the trends is their systems are becoming smaller, and there is, of course, the need for high accuracy in the navigation aspect. So very interesting for us to see that. Here you can see as an example, yeah, this is a plant that it has a disease. So yeah, you could have a person that is analyzing this, but you can also have robots that are doing this analysis either by flying at the on it and doing some camera picture analysis in a very detailed way, or you could also have robots which maybe have a better view of those problems as well, and maybe the robot could take an action behind those plants as well. So very interesting. Here you can see two real applications of agriculture. Two companies are already doing that autonomy with robots. Here is a CNH Robotics, and this is a bigger robot, as you can see here. And this, I would say, one of the most known, if not the biggest company in agriculture robotics, which is a French company called Nayo, which uses that high accuracy RTK in order to perform weeding. So very interesting application. They have robots which are quite big or quite small as well. So in agriculture, you will see, again, those type of big robots. They are very close to the tractors. They just remove the cabin. That's what they do. And then they have full autonomy there. In terms of the perception, there's not a lot of perception. They are mainly doing actions behind it. And yeah, that, because it's such a big machine, dangerous machine, as you can imagine as well, there is a problem of reliability in the position inside. They need orientation when they are navigating. So yes, they need this high-end GNSS technology behind as well that is safe as well. You will have a bit mid-size, which is kind of, as an example, this robot that I tell you here. In this case, it's a weeding robot, but you will find many other examples for different agricultural applications. They have precise. They really need that precision when they are navigating. And that's the big value of these robots itself. If they have that centimeter accuracy, then they can perform much better weeding tasks, which are really very precise on the job that they are doing here. Or you will have small robots. You will have, as an example here, this is a robot that is just passing through the crops, taking pictures and doing an analysis. So the perception aspect is quite important, but they also need a position. And the very interesting part here is that when they are navigating through these crops, there is a lot of GNSS signals that are actually hidden due to the crops. So yeah, you need also more constellations, more signals that can help you to have a better navigation aspect. So yeah, this is again just a summary of those requirements that we get to see in the GNSS and in the inertial navigation systems, which again are combining GPS and IMUs. Yeah, we get to see the requirement for accuracy, for absolute heading sight, for the orientation and depth reckoning. Why depth reckoning? Because sometimes they are navigating very close to trees. So when GPS is not available, they still need to operate somehow as well. And some of them, they are also very close to the farms. Maybe you will have small farms, but sometimes you might have a bit of more obstacles behind it. Integrity for safe operations is very important, again, because of these bigger robots, and not only because of the safety, but also reliability. If this actual robot goes from your farm to the neighbor's farm, you will have a lawyer behind you because it's a big insurance problem that happens there. Or if your robot makes a big mistake, then of course it's also an insurance liability problem behind. I will talk about later about ecosystems, but there is something important that I just want you to retain for a while. Is ROS, the robotic operating system, which is something that is interesting to know what it is and what it does also in terms of GNSS aspects. So yeah, I think we have some customers, and yeah, they basically confirm the importance of that navigation. Many of them are GNSS, but others are also starting to use INS because they prefer to just have a navigation element in different environments. Logistics. So logistics is another important element where you will see already today quite a lot of robotics, AGVs. You will hear the name AGV, automated guided vehicles, which are basically operated boards. You can see it here above, and they are basically moving containers from one place to the other. And I can tell you has been a big explosion in the automation of that. Working in logistics is quite dangerous. You have a lot of containers, big cranes, vehicles passing by all the time. So you can imagine a lot of people get good money when they are working here because there is a lot of safety issues behind it. So that's why they are trying to optimize that also with robotics systems behind. And well, here this is a bit more advanced, but definitely trucks that will also become, of course, closer to the autonomous vehicles. But when they are operating in the logistics environment, they need to have different type of perception and reactions in these environments as well. Delivery robots, which is also very close to the logistics side. And this is what I call the an efficient burrito deliver here. If you just consider basically what's happening is that we want to save basically a lot of millennial people from the start. Why? Because at least in America, there is around 20 million deliveries every single day. Half of those deliveries that have to be done are walking distance. So this is very interesting to see how this is evolving, this last mile delivery aspect. And 9 of the 10 deliveries that are done today are unfortunately by cars. So they're very ecological, as you can imagine. And it's a problem when you have, okay, one burrito, but when you have 20 million of deliveries, then of course you have a lot of tons of pounds of burrito that you need to be delivering every day. So this is a problem not only for governments, because they see, of course, a problem of traffic, they see a problem of ecology, etc. But it's also a problem that some companies on the delivery, last mile delivery aspect are trying to solve. So that's why these delivery robots are going to start coming more and more. There is still an element of adoption in the coming years. It will take some time, I would say, especially with the drones, because drones, yeah, they're a bit more dangerous in the air, etc. So that will take even a bit longer. But we already see, as I told you, some delivery robots in universities and other places where the technology is being tested as well. So very interesting element of robotics in the delivery side. And as I was telling you, yeah, if you drive, sometimes you maybe have to order, etc. So yes, there is 1 hour. If you try to do a bit more different type of deliveries, maybe you can reduce that. But at the end, people want to make that with a robot in a very efficient way, from the request via your mobile phone all the way to the delivery in just a few minutes. So this is an important efficiency that people are looking in a commercial, economical way that will make a big difference in what is called this last mile delivery aspect of the systems. Yeah, okay, I will not emphasize it more, but yes, of course, you need, people want the safety of their delivery package. They want a different type of load. They need accessibility because they're operating next to people, next to obstacles. Some of these robots need to be acclimatized, because if you are putting, I don't know, some cold beer or something like that, of course you want it to be cold also at the end, and they want to be compact as much as possible, although I have seen some delivery robots that are a bit bigger because they really have a lot of merchandise that are trying to deliver there as well. So yeah, the market will keep expanding a lot. America is I would say the bigger adopter, I would say, of the technology, but some of this technology has been developed even in Europe. As an example, yeah, companies like Starship Technologies, which was an ex-company that created Skype. So they also this specific type of robot, and now they are in the delivery worldwide. So very interesting to see the applications. As I told you, these robots, especially in the delivery side, they are very close to autonomous cars because they are using all these sensors. Cameras as obstacle sensors, so they have tons of sensors. So many of them believe that actually GPS is indeed just an extra thing there. But as we mentioned and we discussed the importance of GPS and the importance of GPS safety as well, because unfortunately you can still jam or spoof these robots and deliver a package somewhere else. Quite important. So this is yeah, this is going to evolve as the technology gets also more and more adopted as well. Drones, okay, as I told you, yeah, normally I consider also drones as some type of flying robots. And yes, in the delivery side, you can see here below, there is also quite an important element of what customers are asking us, mainly security, as you can imagine. These drones could be phoning, they could take the package somewhere else, etc. So there is very important demand on the anti-jamming and spoofing technologies that you have there. This is a jammer, as you can see here, that could be disturbing that navigation of the drone itself. So I would say mainly in the drones is where people are very, very concerned, because these things can fall on your head or can fall in somebody's property, and nobody really wants that. So that's why the government is paying quite a lot of attention in certification behind these things. But as I mentioned, we will get to see those problems happening in the ground robotics side as well. And as I mentioned, lawn mowers, important market where high accuracy is being used. They started to use very similar technology as your vacuuming at home itself. So they are also using some sensors behind there as well. And that's how they started to work. And actually, when they were moving in the garden, they started to move very similarly to a vacuuming robot, which is all directions, crashing everywhere, and trying to find the obstacles behind it. So what people found in the robotics mower market is that it's just not efficient for an outdoor robot, especially if you can use precise GPS. A lot of these robotic mowers, they were using what is called the wire. I don't know if any of a robotic mower there, but they were using a wire, which was a cable that was run in the whole garden in order to limit the geofencing of that robot so that it would not go outside of those limits itself. That's basically how it was doing it. Again, not efficient. You had to put out there in your whole garden, and it's a complicated process. So RTK GPS positioning became as a very good idea, and this is what's happening. The robotic mowers companies like Husqvarna, Stiga, and other companies are already integrating RTK systems in their robotic mowers. Well, of course, you have applications of your home garden, but there are also other big gardens. You can imagine golf courses or other type of things that are doing this mowing in sports fields as well. So very interesting market, and how that one is also developing quite well. By the way, the first robot that existed was the sheep in the robotic mower, which actually just cutting the grass in a more efficient way, maybe. But yeah, of course, that's now being replaced as well. Again, on the logistics, port automation, again, just an example here. This is normally what they are called the straddle carriers. Okay, I'm not sure I will consider these robots. They look like robots, as you can see here, but they are also integrating a lot of autonomy, which is the same type of technology, again, that is being used in the robots as well. So yeah, very interesting, because of course the environments that these machines are operating is in very difficult metallic environments where there is a lot of GNSS, lots of reflections behind. As I mentioned, again, mining is also very interesting, the type of autonomy that exists there. This pit mines, so normally there's a problem because you have a lot of obstacles in terms of visibility of GNSS, so they really require a lot of reliability on the GNSS, and yes, an inertial navigation system is also often required. But as I mentioned, these huge vehicles, because actually they are huge vehicles, they are also fully automated in terms of using, again, very similar technologies, and they also need inertial navigation system for that depth reckoning and for better guidance as well that they are performing. So now I will talk about technologies on the GNSS side. What is it really important side? We have some analysis performed by the robots and some action done by the robots. I call it the double A side analysis, because they are taking pictures, sensing temperature, etc., or other things. And actions, it could be an arm, could be a wither, could be many different things. In those two aspects, you will need navigation. You will need some navigation technology, and therefore you will need a GNSS aspect. Why? Because if you are doing analysis, you want to geolocate the analysis that you are doing, or if you want to do an action, you want to do it in the right location as well. So at least the trends or demands that we get to see in the robotics side are the following. They need accuracy. And this accuracy is needed for the position, but also for the orientation side. So in that aspect, they are using either one single antenna GPS. Sometimes they are using dual antenna because they need a 2D orientation, and you can obtain that with 2 GPS systems. Or sometimes you are using an inertial navigation system, which will give you the 3 angles of orientation and the position in a very accurate way. So that's normally what we get to see in those systems. Low power consumption. This is very important. All these robots, when we are talking especially with small and mid-sized robots, they are operating with a battery. And this is all the explosion of electric cars. Need efficiency. They need the lowest power consumption so that they can have a better life, basically, in the operation itself. They need an ease of use, and this has been remarked by a lot of our customers, especially in the agricultural market. In the agricultural market, people are not used to robots. They are used to machinery. They are used to not necessarily always technology. So the technology has to be very simple for them to adopt. If it's an RTK system, they don't even want to know what's a corrections or what's a base station or whatever. They don't want to be aware of those things. They just want the technology to work directly. So that ease of use and the monitoring that those integrators have to do has to be quite important. Networking and sensor integration, as you mentioned, Eduardo, a lot of these sensors are using timing information, so they need to be also connected using these PPS pulses in order to synchronize each of these sensors. And many of these robots are also now starting to be connected. So it's not only going to be one ag robot that you might see multiple agriculture robots operating in the same farm for efficiency. Maybe they will be small robots, but that could do a big increase in productivity as well. Environmental, when we are talking about robots going out there, that means different environments. So I can tell you, as a GNSS company, we need to be dealing with all different type of vibrations, with all different type of temperatures, with all the different types of humidity, with how people are washing the vehicle, because sometimes they are using these water pressure machines, so they want to have the best protection in the box where you put the GPS receiver, so that is not destroyed. And again, that element of security, reliability of anti-jamming and spoofing, or any type of redundancy, is definitely going to help not only the adoption but also the certification aspect that will come in the coming years as well. And you can see it a bit here. This is actually one of our customers. They have a robotic mower operating in solar panel farms. It's a very interesting application. You can imagine these solar panel farms are huge. Many basically meters of area that you need to cover. And the problem is, of course, grass is growing, so you need to cut it. And the problem as well is that there's obstacles. So that means solar panel farms are also giving reflections of the GNSS signal. So you need to have a very reliable GNSS system to operate. And the more signals that you have, indeed, as visible here, this is almost a receiver with all those signals. Yeah, it can operate better. So yeah, they are actually using a receiver, which helps them to have a reliable operation in these solar panel farms as well. Drone delivery, we mentioned that safety element aspect. So yes, they need precise position, correct vehicle orientation as well, sometimes to land properly in either in the house where it's delivering something, or also maybe in the vehicle that is dispatching those goods as well. It's my delivery aspect. Reflections, as we talk about logistics, lots of reflections in the metallic containers is the worst environment. Many GPS systems just don't work here. So normally a navigation which is combining GPS and IMU, which is a GNSS INS system, will really help them in that aspect. And we talk about reliability, which is the big important question in autonomous systems, not only robots, but also autonomous cars. Is okay, maybe I'm accurate and I already have a position and I have kind of a safety bubble where I can operate. But if one of my sensors becomes giving me an error, then I start to become a bit worried. I just kind of flag an alarm. Or at some point, if I have a big error, then I have a do not trust area. So I need to stop that system from operating or give control to other sensors to operate. So this error reporting on the GNSS. I mean, when we are talking about GPS, we're always talking about position. But one of the more elements also for this sensor fusion is error reporting, truthful error reporting, because otherwise you could have problems in the safety element of the robot as well. We talk about jamming, and these jammers are often used by transport industry. So if you have a robotic mobile operating somewhere in a golf course, yes. If you have a root behind it, yeah, you will definitely jam it, and you could cause some damages and some accidents behind it. So that problem of jamming is quite important. Now, we not go in detail, but there are two elements of cybersecurity or cyber security in GPS, I call it, which is jamming and spoofing. Jamming is basically destroying the signal of the GPS using one of these jammers here, very cheap one, $20 US, so 20 euros. You buy it on eBay and then you just destroy the GPS and that's it. Or you have a spoofer which will take the vehicle and location. And yeah, I would not like to have my delivered package to a wrong location either. No? So very important problem. Normally jamming is very common, I can tell you. We get to see it a lot. Spoofing is less common. However, actually I was giving another talk this morning about spoofing, and you can see that in the last 3 years, the amount of events of spoofing have really increased quite a lot due to geopolitical situation, of course, as well. But the technology is also becoming available to everybody. So spoofing is becoming an important problem as well. In terms of technology, what can you use for orientation or for the heading is normally called an orientation of the vehicle? You could use what is normally called the velocity or course over ground. Course over ground. If you have a car moving in a certain direction, then you will see how the position is changing over time. So that will tell how the orientation, but that means that the vehicle needs to be moving in order to have that course over ground information, to have the orientation of where the vehicle is moving towards to. You have also other sensors, magnetometers, you have gyroscopes, or you can have a dual antenna GNSS system, two very accurate antennas which give you a very precise position, and therefore you can compute orientation of that, and that we integrate as an example in a single module or cells, so very efficient for some of these robotics, and no extra, you don't need two GPS systems, you just do it with one single GPS system that allows you to connect two antennas. Or you use indeed, as we discussed, an inertial navigation system which is combining a GPS with an IMU. This is just to give you a bit of the advantage of a dual antenna GPS system. Sorry for that. The first one is to have better velocity heading. So again, if you do it with coarse over ground, you will not really have good information, but actually if you use a dual antenna system, you will have not only the orientation, but also the velocity information. So that can also help you quite a lot in a robot itself. Another advantage of a dual antenna systems is that you don't have any problems with magnetic interference. As an example, if you use an IMU, you will have a lot of problems of interference to magnetic sensors or other disturbances that might be occurring around. An example, metro lines is a place where there is a lot of interference in the magnetic side. So yes, it's much better sometimes to use a true dual antenna for the orientation. You will, of course, maximize the heading accuracy and the stability of the system. It's also ideal for vibrating environments, because if you use IMUs as an example for the orientation, they are kind of mechanical components, while if you use a true dual antenna system, you will not have those effects. And it can also be very efficient for very dynamic environments, which is fast movement, but also can be very efficient for slow movement environments or small movement robots. You might see that in agriculture. Agriculture robots are very slowly sometimes in order to take the right pictures. And if you want to have the proper orientation, if you use an IMU, maybe it's going to have a bit of bias because it's not having enough kinematics, while if you use it, then it's going to be much better in that aspect. So compare this, just to compare a bit the inertial navigation system, the first dual antenna solution. This is an inertial navigation system, which is combining what I would say the best of the two worlds of a dual antenna system or a single antenna position system, GPS, together with an IMU. So the combination of those two technologies will help you a lot. Why? Because as we discussed, the dual antenna has a lot of advantages, but it has a problem. It needs the sky view behind it. Well, the IMU does not need a sky view. So if you combine those two things, you will obtain a much better efficiency in the inertial navigation aspect. You will have absolute positioning, absolute heading, full 3D orientation. You can initialize orientation quite fast as well, and you will not have any drift in the solution itself. So navigations in robotics, many of them are using IMUs already today. The system already allows them to use IMUs. It's another way to do it, but as you can already do it directly integrated in the GNSS INS system, which is because you do the sensor fusion at a very deep level in the navigation aspects as well. This is actually just some recommendations for different type of applications where you could use either dual antenna or inertial navigation systems or gyro compass type of sensors. You can see as an example for, as we discussed, for some of the heavy machinery which could be in difficult environments, it's better maybe to use also some inertial navigation systems. Railway is often with a lot of obstacles of GPS, so yes, you want to have that. And yes, in the navigation side of robotics, I would say I have seen the two. I have seen people that say, I just want for orientation a dual antenna system, but I also have seen people that say, you know, I prefer to have a 3D orientation and also the value added of that reckoning that comes from this integration as well. So I have seen the two schools. These two schools will evolve more because right now, indeed, people prefer to do the sensor fusion themselves. But I can tell you in the future, they will have to focus more in the final application. So they will prefer to have an integrated system from themselves. I will talk About ecosystems, this is kind of the general last I have. What are the ecosystems around the robotics? So if you want to do robot application development, normally people develop a type, and then they need to have some robot components that they put together. They need to develop some firmware for that robot. And then, more important, they need to work on drivers that allow you to connect to the different sensors. And I will come back in a minute about what I mean by that. And then, of course, they can do integrate and test or do simulations and do a proper deployment of the robot. This is normally I would say, the development flow of what you will see with the people creating robots out there. Very important, again, you have a motor in the robot itself, and you will always have a computer, right? That computer is doing the sensor fusion of those sensors of navigation, but it's also doing communication via Wi-Fi or GSM, and it's also having this IMU, which could be either as IMU or again could be integrated in the navigation. But this is normally the general diagram basically of how robots are operating. So if you are an integrator and you see all those components, you see components of the drivers, there is a lot. There is a lot. And you will get confused with all those technologies. So yes, your engineers want a very simple way to integrate all those sensors in the easiest way, especially in a robot, because there is a lot of electronic components in this autonomy part. Computers, communication, lidars, cameras, autopilots, controllers. So very important to see what could be done there. Engineers really want something fast and easy for their deployment as well. So again, here, normally what people will use is some technology that allows them to connect all these sensors. And this is what you will hear about ROS. I don't know how many people of you are familiar with ROS. Okay, Eduardo, you might be, you might know even more than me, but ROS is indeed what is called the robotic operating system. And this robotic operating system is allowing you to connect all those sensors and to perform all the different that the robot will be doing. And as an example, in order to have the GNSS working, you need a driver that can communicate to that ROS system in order to have the position side of that. And then, of course, there is sensor fusion done by ROS. There is a hardware architecture, simulation, etc., that people can do around all this robot integrating a GPS system. Let me go here. So what is ROS again? ROS is software. So it's a software that you put in a microcontroller or in a computer in order to have the different tasks of that robot. You will have what they call normally ROS master, that's the operating system that is communicating to multiple nodes. What's a node? Could be a GPS system, could be a camera, could be a lidar, could be different things. And in order to communicate GPS, as an example, to an IMU or to another computation element, there is a publication of what is called topics. And a topic will be the XY set of my position, or will be the orientation, heading, pitch and roll of my vehicle, or something else. This is basically ROS is just communicating all those different sensors together in a very simplified way for people so that they can do further development and automation of the robot. The advantage of ROS is that it's available open source, and that means there is lots of drivers for sensors. You will find them from lidars, etc. Every company will have its own drivers. Septentrio has its driver, which is called Rosaic, which was developed by a student, and he keeps helping us and maintaining that driver. So you are welcome to contribute to that open source project. You will have it for the other sensors as well. So all these open source drivers, they communicate to the main ROS environment in order to operate properly and in order to perform navigation. So you can see it here. The GNSS sending data to that navigation stack, which is a component in the ROS environment itself, which is generating the navigation from the robot from one place to A to place B. And it's not only the GNSS, again, it's other sensors that could be using for the navigation aspect. So that's basically how the navigation stack works. You can see that bit more in detail here. A GPS system is connected to a driver of the ROS environment. This is something that every company develops. Every GPS will have its own driver in order to operate, in order to read the data from the GPS and convert that data to something that ROS can understand. And then you will have a localization technology within ROS that is doing also Kalman filtering and all this sensor fusion for you in a free, automatic, open source way in order to have the navigation of the robot, the path planning, and then the robot control behind it. So this is normally how the flow of the communication in a robot works. Again, ROS-AIC is available. It works in our different receivers. It supports not only position, but also orientation information. And yeah, you can use serial communication from the GPS, TCP, or different communications in order to be able to interact with the ROS environment aspect. For orientation, the same situation. We provide messages that can be read from the GPS receiver, and that can be translated to the ROS environment in order to operate in a very simplified, easy way for the people of ROS. So that's why a lot of people that say, hey, I want to use your GPS receiver, but by the way, I need ROS. Yeah, the main reason, because they just to be focused on the operation of the robot and not in the interaction between GPS and the communication aspects as well. Just for your information, there are two ROS versions. There is ROS 1 and ROS 2. This is more in detail, but ROS 1 is basically what started already since 2007. It became very, very popular. It's working mainly on Linux, using some programming languages like C++ and Python. And now there is ROS 2. So many people talk about the new version of ROS, and it's kind of a completely different environment. But it works. It has the same kind of philosophy, communication between nodes. It's just that the programming elements are different, but it has been developed in order to provide more security, more real-time control, more distributed processing. It works in more operating systems: Windows, Linux, OS X, RTOS, which is real-time operating systems, really more embedded. So ROS 2 is really becoming more the professional side of ROS, while ROS 1 has been highly adopted, but many people are now trying to migrate to ROS 2 in that aspect. So if you want to choose between one or the other, I would say, yeah, ROS 1 is the easiest to start because there is lots of documentation. You can always play with ROS yourself. You don't even need a hardware robot. You can do simulations on that. You can play with that. So if you want to start in the world of robotics, I would say play with ROS. And ROS 2, yes, is a bit more advanced. It's going to be more for the professional users, but lots of information out there. ROS 1 will be killed and ROS 2 will take over at some point. They call them different versions of turtles, as you can see, they're melodic, kinetic, etc. But yeah, ROS 1 will die at some point this year, so people will migrate there. In terms of ecosystem, you can use GPS systems. An example, we have an open source a mosaic hat that you can connect to a Raspberry Pi, and then you can put in the Raspberry Pi ROS and then have the system working. That's a nice idea. We also have another open source hardware, MOI, which you can also produce yourself and has wireless communication. So there is a lot of open source that we also generated in our GNSS site. We also have a very simple to integrate Mosaico. We call it this kind of kit. So if you want to play, feel free to just order it online, and that's it. You don't even need to contact me. You can purchase it directly with your credit card. It's not that expensive either compared to the prices of GNSS in the past. So definitely interesting to use. And if you want to play with robots, here some companies that provide the platforms already ready for you. ClearPath, Robotics, Robotnik, Husarion, and they know much more about robotics than myself, but definitely worthwhile checking what's out there as generic platforms, because this is where people start developing prototyping robots, and then of course doing very specific tasks there. So this is actually just studies of Septentrio. Again, I mentioned Nayo, Renu. We have also Citia and other companies already integrating. So feel free to look some of those use cases in our website where we have more information. And I think this is my conclusion slide. Again, robots are in the real world already today. I cannot say that they are in volume, except robotic mowers, which are already in volume. But the other applications will start to develop or be adopted slowly. And they will need some reliable accuracy, positioning GPS systems behind. So yeah, that's one of the main reasons also why Septentrio robotics is very important, because we see this need for reliable, for accuracy, for safety, which is a place where Septentrio plays the main role there. So that's it. I don't know if there are questions at this moment.
Thank you so much, Gustavo. It has been an amazing lecture. We'll learn a lot about robotics and so on, the different environments and applications. And it's a huge world. It's a really huge world. Well, guys, do you have any questions? If this is the case, please, you can just take the mic and try to ask us. Septentrio is working in every single different environment application. You have products for everything, right? When we are talking about robotics, what is your, let's say, in your business, the robotics, what does it represent, let's say, in terms of, figures, main figures?
Well, maybe I'll just talk about percentages today. If I will talk about mid and small robotics, so not the big vehicles aspect, because big vehicles is an important market for us, but smaller vehicles, I would say that's still somewhere around 20% maximum, I would say, but this is growing rapidly. Yeah.
What is the main application that you are working for? Maybe because you have mining, agriculture, and so on, but I'm pretty sure that there is one which is the most, right? Or
the more important that we see growing is agriculture side, in the mining side as well, and in the construction. Small are still not there, I would say, but possibly logistics is the other that is also growing quite a lot. Yeah.
And between all these applications, let's say, I mean, most of them, I guess, maybe not all of them. A lot of them, they are demanding precise solution, right? Accuracy of few centimeters instantaneously, maybe, right? I mean, it depends on the application and so on. And for this, I mean, Septentrio is providing with the solutions based on PPP and RTK as well in both solutions, yes?
Well, what is very interesting, if you take a look at the agriculture market as an example, the agriculture market was using PPP navigation systems. Why? Because they were cheap. They were cheap, and they were also operating in a worldwide areas. So that's basically where they started to use PPP technology, areas where there is no access to a network of corrections. The same is going to happen with agriculture robotics. However, if you take a look at how at the moment agriculture robotics is growing, it's mainly growing in areas which are very developed. So there will be infrastructure around it. So places like California, etc., at least for agriculture robotics. So the requirement for PPP is not that important. But there are other technologies that are becoming quite interesting, positioning most alternatives to PPP, which is SSR. So SSR is becoming, I would say the future of how agriculture robotics will pick up position inside.
When you're talking about SSR, I mean, you are talking about it's PPP RTK, let's say, right? I mean,
you can PPP RTK. Yeah, I try to distinguish PPP by itself because PPP is long convergence, not always high accuracy. So it's mainly the long conversions that you have with PPP systems. PPP RTK or SSR is fast convergence, which is what these people need.
Exactly. And then in Septentrio, do you have your own PPP RTK service, correction service, or
No, we don't have a service there. You will see somewhere soon, I would say. What we are is agnostic to service. So many companies is you have to use my service in general. Even if they don't say so, they promote very strongly their service, or they make it a bit more difficult. Septentrio is working with different partners, I can tell you, in order to have agnosticity of corrections, so that you can choose, like in your phone, you buy your mobile phone, and then you can use different services that you want. This is possible, of course, as well, if you integrate in an intelligent way the technology aspect as well.
Then as long as you are more concentrated then in the positioning engine, right? I mean, at the end to estimate a position, for those safety critical applications where a wrong position may derive, let's say, people dying and so on, right? Do you have also solutions in this sense? I mean, trying to develop fault detection and running solutions at the receiver level to get rid of this kind of errors, and then to provide let's say high safety level and levels of confidence in the solution, like 10 to -9 per hour. Yes.
Well, in terms of certification of GNSS, we don't have that. So, as an example, automotive market already has some certifications aspect. That's not really our goal. In the robotics side, however, there is no real certification yet, and it's evolving, and it's also a big question on how the other sensors have to be certified. So what we provide as a solution is what I call the more reliable GNSS system in terms of anti-jamming and spoofing, and also in the error reporting. That's at least where we are very well recognized by external people. So it's not me saying it only. So those are elements that you need to use on the safety. So error reporting, if you have a truthful error reporting, then you can rely much more on the GNSS sensor and to avoid accidents behind that. And the other one is the hacking that I mentioned. There we have a very strong protection, which is also a very important element of safety. You mentioned rain. Yes, definitely we have also rain techniques in the measurement side to protect in the system. And yeah, they're quite involved, I would say, thanks to the use of multiple signals that we have in the receiver.
Amazing. Do you have some? We have one question in the chat, which is in precision agriculture, how do you do to combine INS and GNSS? Well, it's very, very technical, but maybe you can go ahead if you want, Gustavo.
Yeah. So as I mentioned, well, there are two aspects. I will consider. There are things. One is I, and the other thing is IMU. And IMU for me is the sensor, which you combine with the GNSS, and then those two will give you an inertial navigation. How we do the sensor fusion inside the module or the board itself. So what we are doing there is I will call it close to deep integration of inertial navigation in the receiver itself. Why? Because we take a look at the measurement information from the receiver, very raw information, and we take a look at the raw information from the IMU, and then we take the best prediction for the positioning aspect in that side. So this is normally how we do it. On the agriculture, as I mentioned, some people require the inertial navigation, mainly because of these possible obstacles, trees, when they are maybe close to the trees area, or possibly close to the farms or something like that. But some people prefer just to say, okay, I just want to stay with GNSS and yeah, maybe avoid the extra sensor fusion. As I mentioned, robotics people, they sometimes do their own sensor fusion. They buy their own IMU sensor, very cheap ones in some cases, and then they buy a GNSS system, and then they use ROS, which is integrating these two by themselves. So yeah, that's another way to do it. Unfortunately, the integration, when you do it in ROS level or in your own control level, you are only doing it at the output of the GPS, which is the position information and the position of the information output of the IMU. So this is already at a later stage, basically, of the use of the data itself. When we do the integration, we do it at the very raw information of the measurements and of the IMU measurements as well. So it's much better to do it from the GNSS receiver point of view.
Mm-hmm. Well, it's true that we didn't address the INS and GNSS or GNSS and IMU sensor fusion techniques. We will do it in next week. In fact, we'll have a particular class on this from an expert coming from autonomous vehicles and so on, right? But at the end, we have as Gustavo was explaining, you have several techniques to hybridize the solution. Either you are doing at the receiver level, then you can use the loose let's say integration or tight integration or very tight integration between both, and then you can have different type of performances depending on how do you do it. You will learn it shortly. Okay, this. Otherwise, well, the last maybe question, I mean, maybe you can go home or go to bed, right? Is that, well, I think we know that you have an Avenger working in your team, right? You're helping it's an internship with you, right?
Yes, yes.
I don't know if you have any open position for more students that may help you in Brussels or in Belgium. You are not in Brussels, but in Belgium for doing this kind of work you are developing so interesting.
Definitely. We have new. So normally, I would say at Septentrio, they call me the University of Septentrio because I bring a lot of students, and it's for different projects. From my role as market access management, I'm quite involved in the ecosystems. So ROS as an example, what happens with robotics, what happens with corrections, PPP, SSR, etc. How can we integrate those things in an easier way? We talk about agnostic corrections as an example. So yes, you are free to apply for an internship at Septentrio, and I can guarantee that they can be quite interesting internships that we make with those students. So yes, right. ICAR, which is still for one extra month working with us as an intern, working in corrections for SSR and other aspects as well.
Wow. Well, guys, if you want to keep in touch with Gustavo, you can maybe connect with him in LinkedIn, or just will let me know, and I will forward your CV to Gustavo. You can maybe just connect directly with him. Okay. Anyway, thank you so much one more time for coming here in the Academy. It's amazing to have you. I hope we'll have you in the future as well in another very interesting thematic. Okay. And so far we can close here. Then thank you so much and see you soon. Okay. Bye, guys. Bye, everyone.
Thank you, everybody. Bye-bye. See you.
Bye.